Hello, my name is Chris Allen and I'm presenting a project on peer-to-peer communication using cloud services and .NET, a low-cost, always-on, easy-to-use solution to customer support. So I think the best place to start with this project would be in trying to understand the problem the project is meant to solve. So imagine that you are a software shop and you have a number of installations of your software out in the field, and you have a technical support staff that is set up to handle issues that might come up with a customer. So a customer calls up with a problem, their server's not working the way they expect it to work and want you to take a look at it. Typically in the past, the way this is handled at our company is that the technical support agent would use a tool such as Remote Desktop to remotely connect to the server and investigate the issue. Other possibilities could be coming up with a custom communication program that uses custom ports over the internet or a VPN to send information back and forth. The problem with these approaches is that the custom solution is a difficult solution to configure, and it requires customers to open ports on their firewalls. Usually customers are reluctant to do things like that. The problem with that solution as well is that you would need to have some sort of a computer to use as an intermediary to transfer data back and forth. You could use an EC2 session, but those can get expensive if you're leaving them on all the time, 24/7, 365. So the cloud is a good way to deal with this situation because it's really easy to set up a solution. It uses port 80 to communicate over the web, and that port is almost always open. And that's really all you need. So this particular project uses Amazon's Simple Queue service, SQS, and Amazon's S3 service. SQS is used as a mechanism to send files or send commands back and forth between the remote system and the local system. S3 is used to send actual files or objects back and forth. So the messages basically are saying what you want the server to do, and the server in this case would be the software running on the customer's system. So your custom software that you've created that you're selling to customers could implement the server process that this particular project uses to serve up files, whether they be configuration files or other pieces of useful information. But in order to tell that remote server from your client what you want it to do, you need to be able to send that server a command, such as what are the files that you have on your system, or get me one of those files, or here's a file, I want to put a file from my system to their system. So those are the commands that get sent back and forth, and we use I use in this particular project SQS to send those commands. So another possible use would be to send a command to the remote server to capture a screenshot, for instance. We're not necessarily limited to files here in that like an FTP type program where you're just sending files back and forth. You can actually also send other commands that might result in different types of data being sent back. Believe it or not, when we've asked for screenshots, sometimes we've actually gotten faxes of a screen. So somebody's actually taken like a picture with their camera and taken that picture, printed it out, and faxed it to us. So that's not all that helpful. They're difficult to read, and it's a time-consuming process for the customer. So it'd be a lot simpler to be able to just send a command from my local system to that remote system to say, hey, give me a screenshot of the current screen, which would contain, presumably the error message that might be displayed on the screen at the time. So Amazon S3 is used to transfer files and objects back and forth. So, the command is sent via SQS, give me this file. If the command is something that's going to return some sort of an object like a file, then S3 is used as a means of getting that file back to the local system. So, some commands may not require the use of S3. Like if I want to issue a dir command to get a directory listing of the current files on the system, I can just type dir into the client program, and the client program goes over to the server and retrieves a list of files in the current directory. Those files are under the 70K limit that SQS has, so the response can be sent back as part of the message request sent the command. But when the response is going to be containing something larger than would fit in the SQS message, like a file, that can then be sent using S3. And the response coming back to the client then would say, here's where you can go to download the file that is also part of this message. So probably the best thing to do next would be to actually just take a look at the solution. So let me minimize this, and I've got 2 instances of the server already running in the background. You could start up as many instances of the server as you want. I went ahead and pre-started these because it does take a couple of minutes once you start a server for those queues to show up to the client. So rather than have you wait, I went ahead and started them ahead of time. So I've got these 2 instances of the server process running. They're running in different directories. So one of them is pointing to, or one of them's running in a directory that has the Nobel Prize winning pictures and files that we used in one of the earlier homework assignments. The other directory has the stars in it. So I just started up this console program. This is written in .NET with C#, so it's just a simple console application. So I have these 2 processes running. I also have a client, and just to show you here, you can switch over to the Nobel directory to see what's in there, and we can switch over to the stars directory to see what's in there, and I can switch back to my client, and I'm going to go ahead and start an instance of my client here and let that start up and initialize. When it starts up, it's going to go out to SQS to see what server queues are available, and we can see we've got 2 server queues that are currently available. Now I'm at my client, what I call a REPL window, which is read, evaluate, print, loop. So it's reading, it's waiting for a command. It'll evaluate that command by sending the command over to the server, and then it'll print the response on the screen and jump back, loop back up, and wait for the next command. So one of the commands in this process is to enum, which is basically to get a list of servers that are currently available. Once I know my list of servers, I can connect to one of them. So I'm going to type into my connect command to go to the first one there. And I could put in the entire queue if I wanted to, but it just matches on the first one it finds, so I can just put in partial names, which makes it a little easier. So you can see now I'm connected to the first server object, and I can issue a command here, and you'll see in the upper left you'll see that the server is receiving the message, processing it, and sending a response back. And you can see now on my client I have a list of the files that are available on that server. I can go ahead and get one of the files, so we'll go ahead and get Albert Einstein. And the response time is pretty decent, better than I expected. So you can see that I just grabbed that file and it showed up here in my directory listing, and this directory listing is again the local cloud client. And if I open that, you can see I did get that file back. So I'm going to go ahead and disconnect from that server, and I'm going to get a list of my servers again. I'm going to connect to the second server. So now you'll start to see some activity on the bottom left side, which is the second server, which is serving up files that are present in the stars directory. And if I get a directory listing there, I'll go ahead and get Audrey Hepburn. And that file was received, and you can see up here she showed up. So I got that. Now I can also, I mentioned before, another, this is not limited to just files. I can also take screenshots, which are very helpful for technical support. So I'm going to go ahead and capture a screenshot here, and we'll see it reads it back, pulls it in, and here's my capture. And you can see there's my active desktop that is currently being displayed because I'm talking to the server, so of course it's my desktop. So I can go ahead and disconnect from here. And that really is pretty much the application. I can also, one other command that I didn't demonstrate here that is available is put. So if I need to move a file from my local system to the one of the remote servers, I can use put to transfer files in the other direction as well. So anyway, I hope you've enjoyed my little presentation here, and there are further details I'm sure that will be posted in the report document, which contains a lot more detail as to how this works. Thank you very much.